Hello students, today we discuss about another interesting part of photoelectric effect, and that means this is the most interesting part is dual nature of radiations and matter. That means today we discuss about dual nature of radiations and de Broglie hypothesis. Okay, so this is matter wave and de Broglie hypothesis. Okay, so actually we know what is photoelectric effect. Last class we discussed about the photoelectric effect and Einstein photoelectric equations. Okay, so today we discuss about dual nature of radiation at first. So what is dual nature? Dual nature means if a body shows two nature, then it is dual nature. Okay, at first we discussed about dual nature of radiation. Dual nature of radiation. Radiation means light, suppose. Okay, so dual nature of radiations. So the phenomena, we know in case of light, some of the phenomena, reflection, refractions, dispersions, all are phenomena related to ray optics, and another phenomena in which the lights are superimposed, that means overlap to each other, that is known as interference, diffractions and polarization. Okay, that means when light shows wave nature. So the phenomena like interference, diffractions and polarizations, this type of phenomenon can be explained on the basis of light particles as a wave. That means light as a wave. That means when light behaves as a wave, then it satisfies this type of phenomenon. That means interference, diffractions, polarization phenomenon can be explained on the basis of wave nature of light. Okay. On the other hand, the photoelectric effect, Compton effect, and some of the scattering phenomena can be explained in terms of quantum nature of light, that is by assuming the particle nature of light. This shows that means some particle nature, that means when light behaves as a particle, then photoelectric effect, Compton effect, and this type of phenomena can be explained by quantum nature of light. Quantum, that means particle nature of light. Okay, so from this explanation, so we conclude that light radiations has dual nature. Sometimes that means light radiations dual nature. Sometimes it behaves as a wave and sometimes it behaves as a particle, and that is known as quantum nature. Okay, so from this we conclude that sometimes light shows particle nature and sometimes it shows wave nature. That means it has a dual nature. That means light radiations has dual nature of radiations. Okay, so next we discuss about dual nature of matter. Actually, dual nature of matter. Louis de Broglie, French physicist. Louis Victor de Broglie. Louis Victor de Broglie, but it is pronounced as de Broglie. Okay, this is known as, actually it is the father of dual nature. Actually, he known as the father of dual nature of matter and radiations. Okay, so according to him, so the material particle in motions, when the particle in motions, then it should display wave-like properties. Okay, that means the material particles which are obtained in motions, then it shows wave particles duality. That means wave particles hypothesis. Okay, so according to Einstein mass energy relations, we know this is equal to, now we discuss dual nature of matter. Dual nature of matter. According to Einstein mass energy relation, we know equal to mc square. That means both mass and energy are equivalent. According to Einstein mass energy relation, that means mass and energy both are equivalent. Okay, so in this concept we can explain that the energy of a particle is equivalent to mass of a particle. That means Einstein explained this E equal to mc square, which is the speed of light. So when In case of radiations, that means light radiations shows dual nature. Then de Broglie considered a symmetry which is known as nature-Love symmetry. That means symmetry of nature. Symmetry of nature. Then he considered and then he assumed that the light shows dual nature. They should exhibit wave nature in motion. That means some of the particle electron, that means Louis de Broglie considered, that means assumed a symmetry. That means electron, proton, neutron. This type of point mass particle. This is a point mass particles. So wave nature when they are obtained in motion. When they are obtained in motion. And when they are at rest, then it shows particle nature. That means the wave associated with the material particle. That means it is a particle of matter. Electron, proton is the particle of matter. The wave associated with the particles of matter in motion is known as matter wave. তেওঁ কি বুলি কনসিডাৰ কৰিছিলে যে কিছুমান কন্ডিশনত লাইট টু ডুৱেল নেচাৰ ৰেডিয়েশনত তেওঁ কৈছিলে যে যেতিয়া ইন্টাৰফাৰেন্স ৰিফ্লেকশন পোলাৰাইজেশন ফেনোমেনা শো কৰে তে লাইট টু ৱেভ নেচাৰ বুলি কৈছিলে নেক্সট কৈছিলে যেতিয়া সেই লাইট টু পাৰ্টিকল হিচাপে কনসিডাৰ কৰে তেতিয়া ফটোইলেক্ট্ৰিক এফেক্ট কম্পটন এফেক্ট এনেকুৱা কিছুমান ফেনোমেনা শো কৰে সেইটোৰ ওপৰত বেছ কৰি পেলাই সেইটো কাৰণে লাইট টু ক'লে লাইট শোজ ডুৱেল নেচাৰ সেইটোৰ ওপৰত বেছ কৰি পেলাই de Broglie এটা symmetry আনিছিলে কি বুলি কৈছিলে যে de Broglie's যেটো hypothesis তেওঁ যেটো wave particles wave like যেটো display তেওঁ এটা wave like মানে display of wave like properties এটা তেওঁ কনসিডাৰ কৰিছিলে তেওঁ কৈছিলে যে এটা particle যদি লাইটে যদি dual nature দেখুৱাব পাৰে that means electron proton neutron this point mass particles should show that means these particles exhibit a wave nature when they are obtained in motion. He point mass particle খিনিও কি দেখাব পাৰে যে এটা wave nature দেখাব পাৰে when they are obtained in motion. যেতিয়া সিহঁতি মোশনত থাকিব সেইটো point mass বুলি কৈছে electron proton neutron these are point mass particles should satisfy wave nature when they are obtained in motion. বুজি পাইছে কথাটো তাৰ ওপৰত বেছ কৰি পেলাই সেই যিখিনি পাৰ্টিকল ক'ত থাকে এটা মেটাৰ থাকে the matter that the wave associated with the particles of matter is known as matter wave ঠিক আছে এটা তাৰ ওপৰত বেছ কৰি আমি মেটাৰ ৱেভটো পাইছো এতিয়া আমি চাওঁচোন কেনেকৈ de Broglie যেটো তেওঁৰ যেটো হাইপোথিসিস এই হাইপোথিসিসটো থ্ৰুদি তেওঁ কেনেকৈ de Broglie যেটো ইকুৱেশ্যনটো satisfy কৰিছে which is known as de Broglie wavelength ঠিক আছে আমি সেই বস্তুটো এটা চাইছো so let's see. Here you see de Broglie wavelength. So according to Einstein mass energy relations, we know E equal to mc square. Okay, actually we know. Again, according to Planck's quantum theory, already last class we discussed Planck's quantum theory equal to h nu. Nu means frequency. This frequency equal to c by lambda. That means v equal to nu lambda. So nu equal to c by lambda. Lambda means wavelength. So it will become hc by lambda. From these two equations here. From equation 1 and 2 they are equivalent that we get mc square equal to hc by lambda then c cancel then we get lambda equal to h by mc. H means Planck's constant, m into c. M means mass, c means speed of light particle. That means that is speed. That means mass into speed, that is momentum. So this lambda equal to h by p. So this momentum, this is the momentum of the light particle. P, this is P equal to mc. P equal to mc be the momentum of light particle having frequency nu. P equal to mc equal to momentum of light particle having frequency nu. Okay, so in case of subatomic particle, that means particle of matter. In case of subatomic particle or particle of matter like electron and proton. This P can be written as for particle of matter or material particle, for particle of matter or material particle. Material particle. Material particle means electron and proton. Electron and protons are known as material particle. For material particle, that means, for example, electron and proton, this P equal to m v. V means speed, that means velocity. Therefore, this lambda equal to h by p. So this is known as de Broglie wavelength. This is de Broglie wavelength. This expression is known as de Broglie wavelength. Actually, it is de Broglie wavelength. Okay, so we know this momentum is related to energy. In class 11 or for energy chapter, we get how momentum is related to kinetic energy. That is P equal to root over twice m into kinetic energy. That means equal to P square by twice m. Okay, so how momentum is related to kinetic energy. Next, the de Broglie wavelength is de Broglie wavelength in terms of energy becomes like this. The kinetic energy of a particle is, we know, this C equal to half mv square. This E equal to this m square v square divided by twice m. That means mv means momentum, it's p square by twice m. So this p square equal to 2me, then p equal to root over twice me. That means de Broglie wavelength, lambda equal to h by p, then it becomes lambda equal to h by root over twice me. This is the expression of de Broglie wavelength, that means de Broglie wavelength in terms of kinetic energy. That means in case of material particles, they are obtained in motions. So we know the electron and proton, these particles can be accelerated through a potential difference. So when the electron and proton is accelerated through potential difference, then again it has a de Broglie wavelength in terms of potential difference. So how this energy, that means kinetic energy, is related to potential difference. Next we get, okay? So we know the energy attained by an electron when it accelerates through a potential difference. So we know the energy attained, that means energy gained by an electron when it accelerates through potential difference V is equal to, that means it gain energy, that means work has to be done. তেতিয়া এটা ইলেক্ট্ৰনে ভি পটেনশিয়াল ডিফাৰেন্সৰ মাজেদি যেতিয়া ইলেক্ট্ৰনটো এচিলাইট হ'ব তেতিয়া কি কি কৰিব এটা এনাৰ্জি গেইন কৰিব so that energy is equal to actually we know E equal to qv so here this E equal to small e into v that means here q means electron itself E equal to small e into v this lambda equal to h by root over twice m e v so this is the de Broglie wavelength in terms of potential difference okay so in case of gaseous particle আমি যেটো পাইছিলো lambda equal to h by root over কি পাইছিলো twice m e পাইছিলো সেই e ঠাইত আমি কি বহাইলো এটা e into v বহাইলো ঠিক আছে আমি একেটাৰ পৰা কন্টিনিউ আনি আছো again in case of gaseous particle we know সেই particle যদি gaseous particle হয় in case of gaseous particle this energy equal to 3 by 2 kT that means average kinetic energy of a gas molecule in terms of temperature which is related which is obtained in terms of Boltzmann constant k is E equal to 3 by 2 kT where k is Boltzmann constant then we get if you substitute the value of E in this equation a equation to the limit put koro this lambda equal to h by root over 2 me e means 3 by 2 kT then 2 to cancel then we get lambda equal to h by root over 3 m kT এই ইকুয়েশন পুট কৰিব লাগিব দেই এটো ধৰিলা তোমাৰ ইকুয়েশন আমি আগৰ যেটো ইকুয়েশন lambda equal to h by p এটো ইকুয়েশন নম্বৰ 1 বুলি ধৰিব পাৰো suppose this is equation number 2 this is equation number 3 and this is equation number 4 e value to আমি equation number put karo substitute the value of e in equation number 2 then we get lambda equal to h by root over 3 m kT so this is the different form of de Broglie wavelength okay so these are different form so now we calculate what is the de Broglie wavelength of an electron in a definite potential difference? De Broglie wavelength to a definite potential difference of kiman hobo. Already we know this is de Broglie wavelength in terms of potential. So next we discuss de Broglie wavelength of an electron. Okay? But again, if question to last year already in 2020 already I said this de Broglie wavelength of an electron. Okay? So now we discuss of this. So here you see the de Broglie wavelength of electron, that is lambda. Already we know electron is accelerated through a potential difference V. This lambda equal to h by root over twice m eV, de Broglie wavelength of electron. So we know this h is Planck's constant, then this h is equal to, this is 6.625 into 10 to the power minus 34 joule second. Okay, Planck's constant value. Already last class we determined the how Planck's constant is to be determined by using potential frequency curve. Okay, so this value is h equal to 6.625 into 10 to the power minus 34 joule second. First one. Next, this m is the mass of electron, that is 9.1 into 10 to the power minus 31 kg. Next, E means electronic charge, that means 1.6 into 10 to the power minus 19 coulomb. Okay, then V is to be varied. Okay, potential difference is to be varied. So if you substitute this value, if you putting this value in this equation, then we get this lambda equals 6.625 10 to the minus like this. Already we know. So this 2 into 9.1 into 10 1.6, then we get 2 into 1.6, that is 3.2, 9.1, 10 to the minus 31, 10 to the minus 19, minus 31, minus 19, then it will be minus 50 and into V. Next, 6.625 into 10 to the power minus 34. Next, this will be 10 to the minus 50. Okay, so if you 8 10 to the minus 50 to the damage root over by here লৈ যাও তেতিয়ালে এটো হবগে ইয়াৰ আধা হৈ যাব, that is 10 to the minus 25 মানে এটো যদি আমি বাহিৰ লৈ যাও, it means it is consider in the outside the square root, then we get 10 to the power minus 25. Okay, it is divided by 2. আকৌ হে minus 25 টো যদি ওপৰলৈ লৈ যাও, then it will be plus 25. গতিকে আমি পালো কিমান 10 to the power 25 হল। আৰু এই 3.2 into 9.1 here the result I mean square root jodi loa hoy by using calculator or by calculating this value. Okay, then we get this is 5.9 by calculating this value. So square root of product of 3.2 and 9.1, that is 5.9 like this. Okay, then dividing this, okay, 5.9 no 5. Actually 5.39. Okay, that is 5.4. 5.4, not 5.9, 5.4. Okay, so if you divide this 6.625 divided by 5.4, then we get 1.227 by using calculation. 1.227 square root of V and 10 to the minus 34, 10 to the 25, then it will be 10 to the minus 9. So 10 to the minus 9 means nanometer. Then it will be 1.227 by square root of V nanometer. Okay, so this is the de Broglie wavelength of electron. This is the most important questions. De Broglie wavelength of electron 1.227 by square root of V nanometer. If you consider this value in angstrom, angstrom means 10 to the minus 10 meter, then it will be 12.27 divided by square root of V. 12.27 square root of V, then it is converted into angstrom. Okay, so this is the de Broglie wavelength of electron. Okay, so de Broglie explained his hypothesis in the matter wave. So this experiment, okay, de Broglie hypothesis was experimentally proved by Davison and Jarmar. Davison and Jarmar experimentally proved his de Broglie hypothesis for de Broglie wavelength of an electron. Okay, so from these calculations or from this de Broglie hypothesis, we can conclude that this de Broglie wavelength lambda is proportional to 1 by P. That means it is inversely proportional to potential difference. Lambda is equal to h by mv. That means it is equal to h by P. So this lambda proportional to 1 by P. So in that case, if P tends to 0 or V tends to 0, P tends to 0 means V tends to 0. That means mass of a particle can't be 0. Kita mass to 0 hobo na. So this, if V can be 0, then lambda tends to infinity. So this de Broglie wavelength is associated with a moving particle. First point. De Broglie wavelength is associated with moving particle. First point. Second point. De Broglie wavelength, for de Broglie associated the de Broglie wave, the particles need not a charged particle. When particle to the charged particle hobole boli kono kotha nai. To associate de Broglie wave, the particles need not a charged particle. Ami belek belek khetrot palo, gas particle khetrot palo, electron khetrot palo, moving particle khetrot palo. In different cases we get de Broglie wavelength. Okay, so from this we can conclude that to satisfy the wave associated with a de Broglie, the particles need not a charged particle. Last, so de Broglie wave. For de Broglie wave, that means de Broglie wave is not an electromagnetic wave. Why? That means electromagnetic wave is associated of the accelerated particles. Accelerated particles of in presence of electric and magnetic field. Therefore, this de Broglie wave is not an electromagnetic wave. Okay, so this is the last part of drill nature of matter and radiations, and already we know different phenomenon, in this case photoelectric effect, and different scientists explain this: Hertz, Hallward, Leonard, and Einstein photoelectric. Okay, so after that we next I come here pasot moi eta ako notun eta video thoi dia him notun eta chapter hote. ঠিক আছে?